Hello and welcome to this lesson about writing two variable equations. This lesson is an introduction to this, so we're going to be focusing on very basic examples. And trust me when I say that later things will get a little more complicated, but that's like, in a year or two kind of a thing. The learning target for this video is writing two variable equations from either graphs, tables, and word problems. So let's start off with some basic starting points. Like I said, this is an introduction, and so what that means is that we're just going to be focusing on two main types of equations. We're trying to lay down the foundation for how to write these two variable equations. One of them is going to take the form y equals something x. The other one is going to take the form y equals x plus or minus something, depending on the circumstances. And so the big difference we have here is we have to ask ourselves, are we looking for a coefficient? So this would be a coefficient. Or are we looking for a constant? Which would be there. So that's the first thing we have to keep in mind. The second thing we want to keep in mind is some behaviors that are different about these two when we kind of keep them in this form. Now, if we're looking at y equals something times x, the graph of it will always go through 0, 0. It will always go through the origin. Now, the graph could look very different. It could be very, very steep like that. It could be a little bit shallow like that. But the thing is, it's always going to go through that point there. So, if we're given a graph and we see it going through the origin, we already know it's got to be this format. If we think about this other one, y equals x plus or minus something, this one is not really going to go through the origin. It might go through up here, it might go through here, it might go through there, it might be down here. It might even, wait for it, go down. Actually, we probably won't see too many things that go down, but it is a possibility. Now, there is sort of one area where both of these are going to be the same. And that's going to be, or going to be really, really similar, I should say. Let's talk about y equals x. If we have y equals x, that's going to be an origin line, just like this. And it's kind of a little bit of both, because it's y equals 1x plus 0. We could have a slightly different variation of it, which is y equals negative x. And so that is definitely more in this category on this side, but it's going to look like that. So that's sort of like the trick question, if you will, of these two. But the big thing we want to think about is, are we dealing with an equation that's y equals something times x? Or are we thinking about something like y equals x plus or minus something? So let's look at some graphs and see how we can do this. Again, the big thing is when x equals 0, does y equal 0? That's the big question. So let's take a look at these two graphs that I have here. We're going to zone in on x equaling 0. And right here, this one is 0, 0. So what this means is that this has to take the form y equals something x. Well, now to figure out what that something is, we simply just use the points to help us out. And we can use any points we want. We can pluck them. So this one is 1, 4. So what I can then do is go y, or not y, I'm going to use the y value. 4 is equal to something times 1. And what this ends up giving me is y has to equal 4x. Because I'm trying to solve what something times 1 has to be 4. Well, that something is 4. The same would be true if I use 2, 8. I'd put that in. Something times 2 has to equal 8. What would that be? It would be 4. Now, over here, we zone in on 0 for x, and it's not going through the origin. This is where it gets pretty easy. We just look right up there. Y equals x, and then it's going to be plus, or if it's up here, so if it's above the x-axis, it'll be plus. If it was down here, it would be minus, but we are above the x-axis, so it's going to be y equals x plus 6. And then again, if we're not confident about that, or maybe it wouldn't hurt to double check, take a point, see if it works. So 1, 2, 2, 8. If I were to take my x value, 2, add 6 to it, Do I get 8? I do. So we're good. Now let's look at tables. So the thing with tables is that they are always going to have a pattern to them. So if you need to, you could use the pattern to work back to 0. So for example here, I'm starting off with two tables that go from 1 to 2 to 3. Well, I notice that I just keep adding 1 each time I do this. Well, that means if I were to go to 0, if I'm going this way, I need to add 1, but if I want to go that way, I subtract 1. Here I can subtract 1, and that would give me 4. I'm looking at that pattern. And what I'm seeing is if I have 0 and it's not equal to 0 here, this has to be y equals x plus or minus something. In this case, it's going to be 4. Y equals x plus 4. Again, if I want to, I can double check any of these values. Plug in 3 for x. Add 4, I better get this y value right here. Here, I look at on the right-hand side, I look at my pattern. What I notice is that every time I go up by 1 here on the x, I am adding 4, but that's not going to help me out too much. More what I want to do is, I can see I am adding 4, but, again, I'm writing multiply when I should be writing add. I'm going this way, which means I could subtract 4. And if I subtract 4, I end up getting 0. And if I go back 1, I get 0, 0. So this means it has to be y equals something x. Well, again, I can use the same trick I was using before. Just figure out 2 times what is equal to 8, and that would have to be 4. So we're back at y equals 4x. So it's the same one as this guy, but in table format. Let's just take a quick look at a couple more tables. The other thing we can do is just take a look at x and y. See what happens when we're doing x's and y's. So here we have just random x values, and I want to take a look at the relationship between x and y. Now again, I could either think it's got to be a plus or it's got to be a multiplication. It could be division, it could be subtraction, but more often than not it's plus or multiplication. Well, in order to get from 3 to 18, I'd have to add 15, and if I add 15, I'm not going to get from 7 to 42. So that makes me think I'm probably doing multiplication. And if I maybe just start doing 18 divided by 3, 42 divided by 7, I might see something common, and what I'm seeing here is y equals 6x. Over here, again, I have some random x values. Again, just take a look at that relationship. How do I get from the x to the y? And what I'm noticing, especially with like these two right here, they just go up by 1. This one also goes up by 1. So that makes me think that I'm probably dealing with a y equals x plus or minus something. Plug my values in, see what I get. 15 is equal to 22 plus or minus something. Well, how can I get from 22 to 15? I would need to subtract 7. So y equals x minus 7. So that's how we would work with tables. Now, it takes a little bit of practice, and once you kind of do a couple of these, you start to pick up on the patterns and you pick up on the way to do this. But the big thing we want to look for, again, is are we dealing with, or we could work backwards to 0 to see if we're dealing with a addition problem or a multiplication problem. If we don't want to work our way back to 0, maybe we can't establish that pattern, just analyze what's going on between x and y. Does it look like you're adding values or subtracting values, or are you multiplying by something? Finally, let's look at some word problems. So for word problems, we have one extra layer, which is that we need to label / identify x and y. Because you might remember how x is our independent variable and y is our dependent variable. And so we want to make sure that we put these things in the right order as we write our equation. Y equals either something times x or y equals x plus or minus something. The other thing we're going to want to do is use our translation skills and really look out for the two main groups of operations. Are we dealing with addition, subtraction, or are we dealing with multiplication / division? So let's take a look at these two examples side by side. For each lesson, it takes 14 minutes more to plan than the length of the lesson. Well, what I'm seeing here, two things. So let's first of all identify x and y. I'm seeing that my independent variable is going to be the lesson length. And my dependent variable is going to be the prep time. The shorter the lesson, the easier it is to prep. The longer the lesson, the harder it is to prep. So the lesson is going to determine how much time it takes. Now I take a look at the words. I'm seeing more minutes. To me, that reads as addition. So I'm going to take my y is equal to my lesson prep time, x, plus 14. Now I have the equation I need, and since I've labeled x and y, if I had a further part of the word problem to solve for one of them, I could easily plug in values because I know what they represent. This is the same variation, or a variation of the same problem, so the x and y is going to stay the same. X is still going to be the lesson, and y is going to be the prep time. Now here it says for each lesson it takes 2.5 times longer. Well, times pretty much means multiplication. So we have y equals 2.5x. There we go. So the video went a little bit longer than I intended, but we did cover a lot of good ground. The big thing I just want to go back to stressing is that we have two types of equations we're looking for. We have y equals something x. We have y equals x plus or minus something. Figure out which camp we're in, and then there is just playing around with numbers until you find the equation that works. So good luck with your homework or practice, and let me know if you have any questions.